Hello and welcome to session 310 in the AI-Safety.com reading group. Tonight we'll be discussing what AI evaluations for preventing catastrophic risks can and cannot do by Peter Barnett and Lisa Tiergaard. In my last presentation, I answered Ravi Krishnan and gave my opinion on the AI evaluations agenda, which, as you may remember, was very dismissive. Now, many smart people are currently working on evals or AI evaluations. And possibly most of the people who in general claim to be working on AI safety would disagree with me when I claim that they don't provide a meaningful level of safety, as I put it last week. And also, because I find this less valuable than, say, corrigibility, I've also studied this agenda less. So I will not make the claim that I'm competent to criticize specific evals. Rather, I will focus on how these evaluations fit into the general strategic pictures, which is my area. So can these evals bring us timely, decision-relevant information? The article we are discussing tonight can actually be seen as part 2 of a two-part evaluation of evaluations. The first article is called Declare and Justify. Explicit assumptions in AI evaluations are necessary for effective regulation by the same authors. And I've only skimmed this paper. It's a criticism of some of the failings of current evaluation work, which I will call incidental in contrast to the more fundamental limitations that we'll be discussing primarily tonight. Of course, incidental safety failings or alternatively failures of implementation are really important. And if the security standards are very bad and plausibly as bad as the authors claim, compared with the security industry for the internet, if they had the same low standards, possibly the modern internet would not be possible. In this paper that we're not discussing today, Lisa Tiergaard and Peter Barnett lists 3 desiderata for the evaluations of frontier AI models. First, they need to be comprehensive. And second, the proxy tasks need to allow us to make some strong conclusions about the actual capabilities of the models. And finally, the elicitation of the capabilities need to hit a certain quality bar. In my limited view, these desiderata are not met for 2 reasons. First is that they are actually a lot harder than they appear. And the second is that the frontier labs aren't really putting as much effort into them as they appear to. Lisa enumerates additional desiderata for evaluating, for using evals to evaluate future models, and here's the list. As far as I can tell, there's little effort on these desiderata, but I'm not an expert, so I'd rather move to the more fundamental limitations of AI evaluations for catastrophic risks. Okay, so let's put the incidental limitations aside and see at the fundamental level, what can AI evaluations for preventing catastrophic risks do and what can they not do? The paper enumerates 2 specific axes of difficulties for AI evaluations. The first is that evals can only be used on current models, but the thing we care about is the capabilities of future models. The second axis is misuse and misalignment, which are really 2 quite different kinds of risks. So in total, this creates 4 categories for evaluation. First, there's misuse for the models that we can interact with. Second, we can try to use the evals to predict if misuse will become a critical issue later. We can also look into misalignment of the current models. And finally, we can try to figure out if misalignment will become a problem in the future. This kind of reductionist analysis is great, but it does have the consequence that the discussion of the last category is almost absent, even though I think this is the most dangerous thing. And this is important because I expected there to be strong potential dis-synergies between the two axes of difficulties. And so the problem is, in a sense, more than the sum of these two parts. Evaluations of AI for existential risk can do some things, and identifying lower bounds is one of them. With sufficient effort, Lisa grants that we can establish lower bounds for the risk of a given model. I think the word sufficient really makes this a tautology, and this rhetoric really strikes me as damning with faint praise. So lower bounds really aren't that valuable if we don't have any knowledge of how tight the lower bounds are. So are the lower bounds that current evals can provide tight? The evidence we have for this appear to be limited, fractional, and not systematized in any way, as far as I can tell. This could perhaps be investigated by looking at historical evals of old models and comparing them to what we can now make the models do. We don't know how tight these lower bounds are. And while people do care about how tight they are, I haven't seen people care enough that they are willing to rigorously investigate how good models are at presenting lower bounds historically. This section of the paper continues with an overview of problems caused by the fact that the evals measure proxies for capabilities. I think it's necessary that the authors include it, but I don't think I think it's given here. To me, the central problem is that in the strategic cognitive domains, we don't care about lower bounds. We care about maximal performance. And that means if we see things like the models making mistakes and hallucinating, this kind of thing does not matter very much from a strategic point of view. Another thing that AI evaluations for existential risk can do is to investigate misuse. In principle, evals can assess risks from malicious use of current models. Excuse me. I'm more optimistic. I think I would skip the word in principle. Because when we're talking about mundane safety, we don't really need very rigorous standards because failure is, in some sense, recoverable. But even this use of evaluation, which as far as I can tell is by far the most common, has a lot of problems. The authors describe some of these problems. I'll skip here because I feel when we predict problems with these events and they don't materialize, we in the AI safety community risk being pattern matched to Luddites or Cassandras, and it's important to recognize where your expertise ends. In fact, I'll present it as a golden scroll here that AI existential risk isn't about the misuse of current models. Yes, perhaps we can learn a little from this area, but I don't think we should make strong predictions. And I also don't think we should get credit when someone builds a virus by using GPT-4. Most things, of course, are not AI existential risks, and evals are useful for some other things. And the authors describe some things, and I do also have my own predictions about how much misuse GPT-5 will enable, but I'm keeping them to myself. There's a concept called idiosyncrasy credits that you spend by talking about this kind of thing, and I think we should be more careful about spending them in the AI safety community. Now some things that AI evaluations can't do. In contrast to establishing lower bounds, establishing upper bounds is harder. A key problem here is that we have no way of knowing if the capabilities are being optimally elicited by our evaluations. I'm not that worried. Optimal elicitation isn't required for upper bounds. Um, but the elicitation isn't really central. Like you need to evaluate the capabilities of the system holistically. Lisa provides some examples of historical under-elicitation, which I'm grateful for. It's important, but it doesn't really establish that this is something that can't be done in principle. And it's an interesting question. So how would you go about proving upper bounds on the capabilities of an AI model? I think that if we were to create some kind of predictive theory for estimating the capabilities that included upper bounds, then we would be able to validate these predictions using evals. And that would be very valuable. There are several ways we could go about this. For instance, we could look at the limitations of the context window. It might be possible to formalize that some complex tasks can't be done with a low context. Another principled way to go about this, to establish these upper bounds theoretically, is to look at limited training data. Like if a model has never been trained on Chinese, then plausibly we could bound its capabilities in this language. Another entry point for analysis might be limitations of how much compute is available for inference. Like you obviously can't write a book without a large amount of compute for inference. And lastly, mechanical interpretability could, if it was more advanced, prove things about the capabilities of a model that we could then use evals to verify afterwards. There are other potential problems for upper bounds, and in-context learning is one. A couple of months ago, we had Buck Schlegeris here, and we talked about the problem with canary GUIDs that are being disregarded because of in-context learning. Another potential problem is from autonomy, which could open some options for increased capabilities. I agree with this, but I actually feel the greatest problem is from new insights causing some kind of paradigm shifts that allow the AI to pull the rope sideways. My personal favorite example of this is the history of matrix multiplication, which seemed like utterly predictable for decades until all these big O improvements we saw were made totally irrelevant by the emergence of parallelism. Okay, another thing that AI evaluations can't do is forecasting future models. Well, at least it can't robustly forecast future models. In a world that took this question more seriously, we would have high quality existing data to look at to get some kind of idea of how good previous forecasts have been. We don't, unfortunately. Lisa points out that a lot of the evaluations require the evaluators to be smarter than the models being evaluated. And this obviously won't be true forever or even for very long. And from a strategic point of view, the key problem is that all of our evals stop working at the same time, which happens to also be the time where a lot of our alignment assumptions work. And that is the key problem. The way I model the emergence of future capabilities is through progress on many dimensions at the same time. I've listed some here, and for each of these dimensions, evals can be used for evaluating them separately. But of course, the joint improvement of all of them, which is what we're seeing, is fundamentally uncertain. So in that sense, I strongly agree with Lisa and Peter here. To illustrate some of the safety assumptions that might break, consider the idea of a safety buffer, or you could call it a margin of safety. Here in this graph, an evaluation is a blue dot, and hopefully this evaluation gives us confidence that a model is safe, even though some scaling happens. And it's possible to do like several evaluations. These could overlap as in this graph. And then the hope from these evaluations is that they're frequent enough to identify precursor capabilities before the models become actively dangerous. This can fail in multiple ways. The required difference between the capabilities that are worrisome enough that will shut down the AI and actively dangerous capabilities might be very small. We've even seen the concept of grokking, which seems to imply that dangerous capabilities could happen without any precursor capabilities being identified at all. It could happen, but I think it's unlikely. In my model of intelligence, I think we are likely to see precursor capabilities because the actual practical capabilities seem to grow linearly and predictably in the amount of intelligence that the models have. And unfortunately, I think that we are in fact seeing precursor capabilities really plain as day right now, and we're not stopping. We are continuing our race towards the precipice. Next, the paper describes some of the additional challenges from models being autonomous agents. Actually, the paper deals with misalignment and autonomy in one section. And in my model, this doesn't really cut reality at the joints. So I've cut them out here, and I'm going to start with autonomy. I won't go into detail with the proposed challenges of evaluating autonomous agents, because in truth, I'm not particularly worried about autonomy. Yes, autonomy can obviously go wrong. But in my model, it's mostly that autonomy causes things to go wrong in rather mundane ways that aren't really an existential threat. And if it was an existential threat through autonomy, then it would also have been an existential threat without autonomy. I do agree that autonomy makes things a bit worse from a safety perspective. But compared to something like the intelligence of the model, that's a way more important factor as I see it. And again, to avoid being a Cassandra, I think I personally try to avoid talking about this subject to keep the conversation on the existential risk. It's sad that this kind of strategic communication is required, but I do think it is necessary. Another problem that is described here is that potential problems could happen during pre-training or some of the training and internal use that happens before a new model can be evaluated. So if there's several steps, you build it first and then you evaluate it, it could kill you before you evaluate it. I agree, this is a problem, and I think it's a pretty strong general argument about the kind of safety work that relies on fine-tuning. Because if you have some kind of safety feature, but you haven't actually turned it on yet, then, I mean, that safety feature won't help you. Now we come to the problem of misaligned models. And this is the thing that I think is going to be the most dangerous. Lisa makes the point that it's conceivable that the models are better at eliciting their capabilities for themselves than we are of eliciting them from them. I think this is an interesting and novel idea that could potentially be a reasonably large factor. To anthropomorphize, like humans aren't really that much better when we are like internally motivated and we have some introspection for how we do things and try to do things in different way. These kind of things matter, but not that much. It's generally not really a major factor, but I'm unsure about this. When we discussed this in the last reading group session, we concluded that we don't actually know. We are pretty confused about this. Sandbagging, which is where models strategically choose to underperform on evaluation, that is in principle a substantial problem for safety evaluations. And I want here to underscore that this isn't a theoretical concern. Like, we have positive proof that this is a thing that is happening. And now what's the point of the evaluations, right? If we know that this is a thing that's happening and still there's no pause and there's no slowdown. It would be great if we had some kind of eval for alignment, and we don't. And we don't even know what that would look like. I'm even more pessimistic than the authors in that I think that we actually have a moderately sound theoretical argument for why this kind of evals for misalignment are impossible. We might never get one. Finally, I think that evals can't help us with is dealing with things we don't know that we don't know. And unknown unknowns is a fundamental limitation of evals. There's no two way about the fact that you can't evaluate a capability that you are not aware exists. I think it's important not to give up on this, but actually put in the hard work required to like nibbles at the edge of what is known to try to figure out what kind of sub capabilities could be possible and could be relevant. More than a decade ago, Nick Bostrom wrote the book Superintelligence, and one of the things that he primarily exhorted us to do was to search for crucial strategic considerations, even though that's very hard. One fundamental source of unknown unknowns is the possible affordances of a different mental architecture. This could be a pretty minor considerations, because even though large language models are very much not humans, we can in fact restrict ourselves to Bostrom's 6 cognitive strategic domains. And in these, humans are in fact pretty optimized and are trying pretty hard. These unknown unknowns will get worse as the human maximum becomes less relevant for modeling. I strongly agree with this, and this is part of my very high probability of doom. Because notice, this is a problem for all the strategic domains, and all the capability evaluation breaks down at roughly the same time. On to recommendations. What does Peter Barnett and Lisa Tiergaard recommend we do about evaluations? So I won't hide my own personal recommendation, which is pause AI. I think a pause is the only strategy that allows a non-trivial chance of survival for us. The authors openly acknowledge that the recommendations they are making are preliminary, insufficient, and incremental. And I then raise the question, why do the evals? Like, evals cost money, effort, attention, and they only provide a false sense of security. So we should consider focusing elsewhere and not do the evals. One suggestion from the authors is to have third-party audits that have sufficient affordances. I mean, sure, we should hit the lowest possible bar, and the frontier labs don't pass this. But even if they allowed third-party auditors like full access to their models, I don't think we should pretend that we would have safety then, because we would in fact gain very little from that, even though it would obviously be better. I think in this work, the authors have correctly identified a number of central problems with AI evaluations. And as far as I can tell, none of these central problems are fixed or even made much better by the auditors being third party. Another suggestion is to use red lines that are conservative and well in advance of dangerous precursor abilities. In my model, current models clearly show precursor abilities, and they have done so for a long time. So stopping, even if we stop at this very moment, I would call that close to the precipice and not conservative at all. Also, we can see that the frontier labs are blasé about like powering through the lines that they've called red, and there's been calls for the lines they have to make them legally binding, and the AI labs have refused calls to make them legally binding, and there's an obvious reason for why they don't want to make it legally binding, and that is that they plan to just power through these lines. Another suggestion is defense in depth for cybersecurity. And like, I care a lot about cybersecurity. I think it's great in general, but when I analyze this model, there seems to be there's obviously a lot of costs through good super cybersecurity, and I don't really see this helping us at all. Like I can't see a lot of universes where like we don't solve the alignment problem, and it's only through better cybersecurity that we don't die. That seems very unlikely to me. A better solution is to monitor for signs of misalignment. That seems obviously good, right? But again, I'm skeptical because we are seeing concretely that our models are scheming against us and our models are faking alignments, and we observe this. And what happens when we have this observation? Well, the frontier labs just accelerate. So what do we gain from these events? And finally, the paper ends with a call for more research. And it's kind of a cliche for research papers to end with a call for more research. But in this case, I think this is in fact the only way forward. And I would in particular highlight uncovering strategic considerations as one field, and corrigibility as another field that we really ought to invest in rather than investing in research for evals. This concludes my presentation on what AI evaluations for preventing catastrophic risks can and cannot do. Thank you for your attention, and see you on the 6th of February. Ceterum censeo, machinam sapientem esse delenda.